Okay, moving right along here. We got a lot of formulas in this unit, which makes it not terribly difficult. Keeping in mind that sometimes, like right now, it's just going to be a straightforward use of the formula. In other lessons, we get into some more difficult things, but again, it's really not terribly tricky. The formulas are a lot easier to decide which one to use than the last unit, I would definitely say. So hopefully we can differentiate between these shapes here. Because now we're dealing with pyramids and cones. Lesson 2 was volume of prisms and cylinders. Pyramids and cones go together. Prisms and cylinders go together. Hopefully you can kind of understand why. Both a pyramid and a cone come to a point. Both a prism and a cylinder, they have two bases. So a pyramid, our formula is going to be the volume, which again is if I stuck a hose in it and filled it up. It'd be a measure of how much water I could fit in there. Or if I filled it up with a bunch of little cubes, right? Again, we call it cubic units for volume. How many of those I could fit? So volume is 1/3 capital BH, where again, B is the area of the base. Like I said, we can have really fancy pyramids. We can have pentagonal pyramids, where the base is a pentagon. We can have hexagonal pyramids, where the base is a hexagon. But the area of pentagons and hexagons is something we haven't learned. So the only two bases you're going to be working with are a base of a rectangle and a base of a triangle. So let's recall from yesterday's lesson, what was the area of a rectangle? We called this length times width or base times height. Again, however you want to call it, we just have to be careful that this base and this height refers to the dimensions of the rectangle, not the height of the pyramid itself. If we're talking about the area of the rectangle, base and height refers to these two dimensions, or length and width. Area of a triangle, what is our formula for that? 1/2, again, 1/2 length times width or base times height. However you want to say that. I prefer saying base times height for triangle. It makes a bit more sense when we see a triangle standing up to go the base and the height. Okay. So we need to keep these in mind, and we have to be aware of what shape our base is so we know which formula to use. Now cones, again, a cone is technically a pyramid with the base of a circle. So the formula actually looks almost the same. We just replace capital B with the formula for area of a circle. So it's 1/3 pi r squared is the formula for area of a circle times the height. Again, technically the same formula, but I'm just giving you that one just so we have it because it's kind of special. R is, again, the radius of the circle base because it's a cone, right? And H is the height. So all we got to do is we have to be able to look at a picture and determine what shape it is to be able to determine the formula. So looking at this, this is a pyramid because it comes to a point. This is not a prism. Remember, think the pyramids like in Egypt, right? They come to a point. This is a pyramid. Now, we're going to go ahead then and copy over the formula for volume of a pyramid. We have 1/3 capital B H. But our B is, again, the area of our base. What is the shape of the base of this pyramid? What is it sitting on? It's sitting on a rectangle, right? So this is, we would call this a rectangular pyramid. I'm just going to go ahead and say rectangle base. So what that means is, for my capital B, we need to use the formula for area of a rectangle. That's what capital B stands for, the area of our base, and our base happens to be a rectangle. So what is our formula for area of a rectangle again? Length times width. So here's my rectangle. What are the dimensions of that rectangle? What are the length and the widths? 10 and 3, right? It doesn't matter which we call the length or which we call the width because we're just multiplying them. We know 3 times 10 is the same as 10 times 3. So here is the area of our base. This is going to get plugged in for B. So we have the volume equals 1/3. Our B is 30. What is the height of this pyramid? How tall does it stand? 12. They put the height in right here because we know heights go straight up. This isn't a height, right? This would be something else. We call it actually the slant height. Heights are straight up and down, yeah? So 12 And then we just got to plug this into a calculator. So we got 1/3 times 30 times 12. Let me grab my calculator here. 1/3 times 30 times 12. We should get 120. Now again, you're not going to need to do this on the test, but we want to be careful. What are our units again? It's inches, but inches what? Inches cubed, that little 3 there, again tells us that this is 3 dimensions, right? Volume is a 3-dimensional thing. So if I had a bunch of little cubes, I could fit 120 of those cubes in this shape. That's literally why we call it cubic inches. If I had little 1-inch cubes, I could fit 120 of them in there. Okay, now this one, once again, what is this shape? This is a pyramid. So we know we're going to be using the formula for volume of a pyramid. It again comes to a point. And before we get to all the numbers we have to look at here, this is a lot. What is the shape of our base? So this is your thinking. We go, is it a pyramid or is it a prism? And then what is the shape of our base? We determined it was a pyramid. What's the shape of the base here? It's a triangle. This is what we would call this, a triangular pyramid. It's resting on a triangle. So again, we have a triangle base. So what that means is, once again, 1/3, the area formula for B needs to be area of a triangle since we have a triangular base. So we have 1/2 the base times the height, but be careful here, guys. This base and this height, we are only looking at the triangle base here. We're not looking at anything else. So any measurements that go with this triangle, including this one here as well, that's like along the flat part, yeah, we're looking at. Do not look at the 11 up here. This is the 11 because that's not a measurement of the triangle base. Major. 1 second, I gotta throw the ball for my dog. Or not. He just wants to play keep away. Anyways, so we have to be very careful because they gave us a lot of numbers here. We've got 10, 13.077, 14, and 14. Following very carefully, this is 10. This is 14 and 14. This middle part is 077. So what we need to figure out is what is the base of this triangle and what is the height? See if you can figure it out. Well, our base and height are perpendicular to each other. If you did not know this, when we have a triangle, I'm going to pull this triangle off here. We have 10 here, 14 here, and 14 here. Hopefully you can see this is just this triangle standing up, yeah? And we have this is 13.077. That's this right here. Excuse my terrible handwriting right now. The base and the height are always perpendicular to each other. So 14 is not the height. 10 is the base. 13.077 is the height of that triangle. Remember, the height goes through the center. So we have 1/2. The base is 10. The height is 13.077. I'm going to erase this here. So you do not use the 14s at all. The 14s do not get used. They are simply distractions to make sure that you know what is the base and height of the triangle. So let's plug this in. We got 1/2 times 10 times 13.077. So we get 65.385. Just because it ends, I'm going to go ahead and use the whole thing. This is 65.385. This is our B that we're going to plug in. So let's finish this off here. We have 65.385. Now, this height, once again now that we are back to talking about volume of the pyramid itself, this height refers to the height of the pyramid. So looking at the picture, what is labeled as the height of the pyramid? 11. This 11 coming up is the height of the pyramid itself. Once again, this height referred to the height of the triangle base. This height refers to the height of the pyramid. So 11 is going to go there. And we just got to plug this all in. We got 1/3 times, oops, delete, times 65.385 times 11. Okay, so I'll go ahead and round this off. We get 239.7, let's say. And what are going to be our units? Millimeters, because they tell us, but it's going to be cubed. So again, they don't get much trickier than that. You just have to be able to look at a picture and know what are the numbers I need and which ones I don't, as well as what numbers go where. Okay, so what shape now are we going to be dealing with here? This is a cone. So we need the formula for volume of a cone, which really, again, is the same as a pyramid. It's just that this right here, pi r squared, oops, is the formula for area of a circle times the height. Technically the same formula. We could say 1/3 capital BH, with the case being that our base is a circle. So once again, R refers to the radius of the circle base, which, be careful guys, because we're going to see this in the next question. The radius is specifically and only the distance from the center to the outside. This is R. This is not R. Do you remember what that would be instead? That would be a diameter, right? The diameter is the whole circle. R is just half. We need the half. So there's our radius. There's only one other number, but what's the height then that we're going to use? 18. Once again, that height goes straight up. So we have, let's plug it in, 1/3. Now I did check your homework for this, guys. You do need to use 3.14 for pi. So I'm going to go ahead and write that. Again, you have a button on your calculator that says pi, but I'm going to go ahead and use 3.14 because it does say to do that on your homework. Our radius is 7. Guys, be careful not to get the radius and the height mixed up. It's the radius that gets squared. If you square the height instead, you're going to get the wrong answer. And then we just plug this all in. So we got 1/3 times 3.14 times 7 squared times 18. We should get a volume of 923.16. I'll go ahead and leave that. Now again, there's no units here. So if you recall from the last video, we can just say units cubed. We don't know if it's inches or centimeters or whatever, so we can just say units. And it's that simple. We just got to keep the numbers straight. Let's go ahead and try one more. Okay, so once again, what is this shape? This is a cone. So we know we need the formula for volume of a cone. Now I want you guys to try this one, but notice what's labeled in the picture here. We have this being 12. We should know what variable that's going to be. But notice they drew this whole line and told us it was 6. Remember that we need the radius. We need just from here to here. This whole thing is 6. Think what the radius is going to be and then try and do plugging into the formula with the whole thing. Okay, so we have 1/3. Once again, I'm going to go ahead and use 3.14. You can use the pi button. It's fine. We're just going to need to round our answer in the end. Now, R is, if this whole thing is 6, if the diameter is 6, R is going to be 3, half of it. So this is the only little tricky thing here, is just being careful that you know what information we actually need. That's going to be 3. And our height is 12. And then we plug it all in. We got 1/3 times 3.14 times 3 squared times 12. This is 113.04. What are our units? Centimeters cubed. Once again, in your homework, you're not going to have to write the units, but I still want to get us in the habit of it for the future. If you continue taking math classes, they will expect you to write the units, so you want to get used to that. So we're going to practice a couple more times in class just to make sure we have this. Going to get any questions answered, and then you guys will try the homework.